I'm writing in languages that I have no business writing, in Python, in React, in TypeScript, like all of these different languages.
There's no reason for our programming languages to be easy for people. There's no reason for us to name a variable in a way that a human can do it.
Writing software has been democratized. Anyone can approach it.
Nobody can really give me guidance if I'm writing code-based systems on when that's going to happen, and it would be purely speculation. So over the course of, the last few episodes, we've been talking a lot about this third user, right? Agents, right? What does this mean from a code standpoint? So when I think about code as what it is made for today, it's for humans to consume, right? And like the abstractions and the patterns in code, it's for us to be able to make sense of machines and to interact with computers. So what do we think about coding conventions in the context of this agent user?
For me to go as a non-developer.
Yeah, the non-developer.
I want to hear non-developer.
Non-developer.
I mean, for me, so I can see that bridge when I first started learning how to code or how to program. Like you would have to learn the syntax first. Like you would have to learn the rules of the language. If you miss a semicolon somewhere, like the whole thing breaks, right? It's this weird quirks for every language that you have to kind of pick up. The biggest shift that I have seen is that I don't need to know languages anymore or a syntax anymore, right? I can jump in and just in natural conversation tell the IDE what I want out of it, and it just gives me the code. So now I'm writing in languages that I have no business writing, right? So I'm writing in Python, in React, in TypeScript, like all of these different languages that, I mean, if I'm building something that requires it, I have the agent or the AI kind of take that intermediary role and just kind of go with it, right? So I think we'll probably dig into this. To me, looking at it from like a human perspective, it seems to me that writing software has been democratized, right? So anyone can approach it. And to be able to do that, the AI has to understand what it is that it's actually writing, the code it's writing. And I'd love to hear your perspective on how you see it from like a dev perspective.
All software is really fast and easy to write until it's a big code base. And then as soon as you have a lot of complexity, that's where patterns come in. Anyone can hack together a app, and AI can vibe code up an app just as fast or faster than most people can like hack together a simple SaaS or a single purpose SaaS or a landing page or something like that. Patterns matter because they allow developers to reason about extraordinarily complex systems in a simple or like portable way. And we use abstraction to do that. And even programming languages are an abstraction, right? Rubylang.org. And it says like Ruby has an elegant syntax that is natural to read and easy to write. Those are human patterns. Ruby was designed for people to read and write. As AI starts writing more and more of our code, like there's no reason for AI or for our programming languages to be easy for people. There's no reason for us to dry up a code base. There's no reason for us to name a variable in a way that a human can do it. Instead, I could see AI, just in time decompiling and compiling logic back from something that is easy for a human to read and write to something that is easy for an AI to maintain and change.
Yeah.
It's like all of the clean code patterns, all the Martin Fowler patterns, all the Uncle Bob stuff.
There's a couple of things you all said that I do want to like focus on. So Shahed, you mentioned something about not having to understand the syntax, but we've also said several times that your job as interfacing with the agent that's writing the code is the editor. So can an editor actually efficiently edit without understanding syntax?
So that goes back to what Austin was talking about. I mean, if it's just machine understanding things, do we even need languages, right? I guess it's more patterns, but
we already don't write compiler code or compiled code. We take JavaScript.
Well, you could, but
no, we don't. Like
it would be wild if you did.
But even like instruct, I guess if you're writing like assembly or like true instruction, but like all that stuff, if you're writing in any language, it gets compiled down to some sort of instruction set. Even the JavaScript we write gets like minified, unrolled, all that stuff. Like we move human readable code into machine readable code or machine optimized code all the time already. And so like Yeah, we edit human code and then we let machines run machine code. What I was trying to say about like all these patterns is I think they will go away and we will start to establish better patterns to make AI understand code bases and large structures better so it can edit. And that might not be large abstractions or using a repository pattern or something like that. Instead, it's going to be things like I'm going to put all of my code into one file because then that can get sucked into LLM more simply, or I'm going to have all of my logic explicit. So I'm going to unroll all of my loops that are like fixed length.
Sure.
Like, because then an LLM can just go change that. Like dry doesn't matter because it can edit both things faster than a person.
You keep saying the word will. And I think that the reality is that people are maybe could be frustrated by the will. There is this foundational shift that's going to happen, but nobody can really give me guidance if I'm writing code bases or integrating with existing systems on when that's going to happen. And it would be like purely speculation. So what do you tell somebody who's actually in the mix and has to bridge this gap until the will happens, right? I think that that's kind of something to focus on. I think it can be dismissive to say, well, don't worry about it because we're just going to throw it in a file. And they're like, but I have to do stuff.
Like today, we still write code for people.
Right.
But we have another user in that code, similar to the agent being another user in your enterprise. We have another user in your code base, which is the AI agents that go and edit that code. And people are already starting to change the way they write code. So it's more effective when you like use Claude Code to do something, or when you use Cursor to go write code. They're figuring out patterns that they can implement into their code bases to make the agent more effective at writing code than even a person would be. And it might actually look like bad code.
I was just going to go back in time. So I was on my way here. I was sitting next to this old guy, and he asked me, "What do you do for work?" Because he saw me I was actually working on windsurf on the plane, and he saw it, and he asked me what I was doing, and I said, I write software. I didn't want to get too much into like what is product design and getting into all that. And I thought he would just be like, oh, that's cool, and then go off. He was actually a software engineer back in the 60s, right? He used to actually put stuff on punch cards, right? And he was talking about these, like a lot of stuff that he talked about just kind of went over my head. But it was, he was talking about 6 bits, 8 bits, and actually writing instructions for the machines and kind of inputting that. All of that has been abstracted away. That's kind of all gone, right? I mean, it's so if we're talking about introducing an agent that's living in your code base and can edit the code that exists there, maybe it's that will that you're talking about. It's just a matter of time. Like we're building slowly towards it.
I think of it as like a really long running refactor, right? Like if you think about segmenting certain portions, one thing that resonates with me is like I need to generate data for evals or something, right? And like that is purely what the agent needs to consume and work with. I can reason about it, right? But I could see how like certain artifacts in a code base that are designed for the agent, we kind of segment them off, right? Kind of isolate them in a certain way. And then if it looks bad, it's like, well, this is not for you. So like step away, right? That's great. It's a great way to end a section about that because we don't know, right?
We don't know. We think ahead, way ahead. At Focused, our teams write software that plays nice with the tools of tomorrow. Let's build something enduring at focused.io.
We had said something about, I love that you called out like the Uncle Bob and like the Martin Fowler patterns and stuff, Austin. One thing, let's dig in a little bit more clearly on some of the things that we anticipate to change, right? So you had said like traditional design patterns. So like, is like solid single responsibility stuff, is that even valid anymore?
The big ones that I see LLMs really struggle with is when you start to add more and more complex layers of abstraction into a code base so that all of a sudden the LLM can't fit in the context window exactly what the code is doing, and instead it's inferring that based off of like naming conventions and variables and stuff like that, and then it does the wrong thing because a variable is named poorly or something like that. So like, does single responsibility go away? Maybe not, because it makes, if you have like all of the responsibility of a domain inside of one structure, then that structure can fit inside the LLM's context window, and then that's good. Now, the context window could expand, but like that single responsibility might still be good for an LLM. And actually, we're seeing that like people are putting like large swaths of code together, actually probably making the responsibility a little larger, but putting large swaths of code together inside of a single file so that file can be copy pasted into an LLM or @referenced inside of an IDE. So single responsibility is probably still slightly important. Open close is like we don't modify objects at runtime, or we essentially, build a domain and then we keep it. That I could see changing, because like patching something over here and not over there could actually be valuable for an LLM because it knows where the patches can be applied and stuff like that. So I don't know if open close principle stays. List-graph substitution still probably stays for a while because we want to be able to substitute like child classes in for their super classes. But the interface overall probably doesn't matter as much, because like the type system as a whole, or the interface of an object as a whole, matters only because it gives people like a way to reason about a domain. So if I have a user, that user can log in, log out, yada, yada, yada. That likely doesn't matter. Interface segregation probably doesn't matter. Same reason we don't design interfaces anymore. We can just have like very procedural code. And LLMs can do very well with procedural code. And then dependency injection is, I'm going to couple class to an interface, and I'm going to inject that implementation rather than coupling the class back to the implementation. But that only matters if I have to. I mean, it might matter in like a test harness versus an implementation case, but like it only really matters in the case of, it makes it easier for a dev to like update things. And if an LLM can like change code near instantly, a couple hundred tokens a second, who cares if I have to go modify, lots of things or tightly couple? So I'm just not that worried about these principles.
I do think it's interesting though, like there's other decisions that humans make in code bases that could be beneficial to agents. So, and I haven't experienced this directly, but anecdotally, what I've heard is that, a strictly typed language like Golang, for example, is actually really interfaces well with an agent. Could you or do you think that that's possible, that there are even human constructs with the way that they designed language? So like think about like a dynamic language like Ruby.
The nice thing about a type system, a super strictly typed language, the LLM can traverse the type system and understand the implementation. But if the implementation can get inlined rather than have it abstracted, then that type system doesn't matter. The abstraction only exists so we can reason about behavior of a larger structure. Right now, because these LLMs are trained on human code, it makes it easier for them to write typed languages because they can actually make sure it compiles, and like they can reference implementation, and if it's Ruby, it's not monkey patched over here and loaded there kind of thing. So there is something that's like nice right now, but I think that where we're headed is LLM. We're going to have LLM based programming languages.
Yeah,
where that like the code that gets written is nothing. It's not designed for a human at all. Mm-hmm. It's just machine code, and we're communicating with that language model in some way that's much closer to real raw English than it is to like writing Python or Ruby or Java or Kotlin or whatever.
The thing I liked about Figma, and like from the design perspective, was that it made people have more ownership over the design process. So you could have, the first time you introduced multiplayer into designs, you could have designers, PMs, developers, marketing folk, other stakeholders. They can all jump into Figma and kind of see like the latest and greatest designs, things that are in flight. Figma and the designs that you create there are still a snapshot of. They're basically static, right? They're just like static mock-ups. They're pictures of what the software could be. Do you think in this world where you have an LLM-powered programming languages, that conversation shifts from a tool like Figma and it takes place in this LLM-powered language?
I think it looks a lot more like a V0 or a Bolt or a Replit, where like you're imagining something and it's like materializing in front of you. Now, there's a lot of software that doesn't have a UI. And so there will need to be ways that the agent can write, read, and run the software and then test the software that does. And actually, I've spent a decent amount of time in Devin. And one of the cool things about Devin, the way they set it up, I can give Devin a an image and I can tell it how to like run my code. It'll boot up a Docker image or a container and it'll say, I booted up your container. I was able to like hit, on the container port 8080 and I got a health check okay. I could hit, /users and I got a list of users. And then actually it'll write test and kind of test its own feature. So if I'm like add, birth date to the user API response, it'll, curl against its container after writing code and make sure that it's there. So like as we get, but I think that's what's going to happen is we're going to get this like kind of full, like, feature to test or QA, like baked into an agentic flow that can, then you're just communicating with it intent. Now these systems get extremely logically complex and like English is like kind of an imprecise language. So I do think that we will have at some point, like there will be we will materialize a new way of communicating large complex changes to LLMs in a structured format that will look like, maybe it looks like Gherkin, maybe it looks like, or maybe it looks like something else, but it's like some logical, like here's what happens if then, given when then this or that, and the LLM can take that and apply that into a logical structure, and then it can even show code or behavior to people that want it so they can test to make sure it doesn't break anything. And like more and more will come out of these agentic code base, agent written code bases will need really good automated testing.
I'm glad you called that out because I don't think that English as the interface to an agent is actually precise. If anybody's actually done a deep dive into the English language, or if you're learning English as a second language, I'm sure that like most people would agree that it's extremely challenging to learn that language, and it's not precise, and it is very subjective, right? And so I agree with you, Austin, that there could be a refinement somewhere between the two scopes of like not as strict as like a programming language, right? Not as wide open as the English language that is behavior driven.
Yeah, like syntax error that you forgot a semicolon, or, like formatting issues, all these things that we do inside of code to make it easier for a computer to understand our intent. Right. That will change because LLMs are actually pretty good at inferring our intent, but we will still have to have some sort of way of communicating. It's kind of like, the PRD has grown as like a really like pretty specific specification on how you build out like a feature. Like maybe that's, that becomes a way of communicating back into an LLM, some sort of like very structured PRD type thing, is a way we go back into an LLM and tell it how to change behavior. Yeah, these things don't matter. Like the type systems are there to help people. If LLMs don't need the types and can change code as fast as a person with types, then we will get rid of types, or we should. Want to talk more about the future of software? Connect on LinkedIn, search for our names, drop us a note, and argue with us. Let's keep the conversation going.
We did talk a lot about patterns, and it's funny that you called out the Martin Fowler thing and how a lot of those old patterns are going out the door. But I did pull a Martin Fowler article, so that's funny, on emerging Gen AI patterns. And so I think this goes along with kind of what we're talking about. The traditional old patterns for software will probably fundamentally change, but there will be new emergent patterns that come up. And it's interesting, I think, in this article, the patterns that they call out. Not one of these is really in that standard kind of solid how you structure your code. It's all about interacting with the agent as that user. So maybe we can dig a little bit more into this article and see what we think.
Yeah, these patterns, for reference, and we can put it in the show notes, but like this is like Martin Fowler talking about kind of the current state of building agents. Yep. And more than saying like a pattern as a problem applied, like when I have a specific problem, I can apply a specific solution. These are like emergent patterns in how people have built agents. So think like when I do my evals, I can either have like a LLM as a judge or self-evaluation, but that's not a pattern. It's not saying when you have a when you have an eval that looks like this, you use LLM as a judge, and the LLM as a judge should look like this. It's not a structural thing. It's more of like an implementation. So I think we're still trying to figure out these agentic patterns. And we talked about them in an earlier episode, but there's like really what we're trying to do is reason about we need to add determinism into an agent stack, because the agent's work is non-deterministic. And the way we add determinism to the agent stack is control how and when an agent communicates with other parts of the LLM stack and calls tools. Yep. And the emergent patterns that we're seeing from that is like who controls which agents talk to which, how do they communicate back to a user, what is the structured output and input, what is the like text-based output and input. Those types of things really matter. And we can dive into some of his specific patterns, but I took from this, like Martin Fowler saying, in traditional software, enterprise software, we've had, the director pattern and composer and, repositories and these types of things, but we don't even know what these are yet for agent development, except for maybe like abstraction of tools and a couple of ways to call, a couple of ways to do eval. But I don't know what you took from it, Shahed, as a non-developer. I'm curious, like,
I think the best way to learn some of the stuff that you're working on with agents is to actually build one yourself, like build an agent. So, like I've gone through, and you go through several steps. And I've gone through exactly these steps. You start with prompting, then you start with embedding, you build your own RAG, and then you kind of embed all of your, we talked about chatting with your own PDFs and your own documents, right? Like going through that process. And the biggest thing that you realize from all of this, look, I haven't gotten into fine tuning or into evals yet, right? That's something I'm still exploring. But the biggest thing that you learn, that the closest and the fastest thing that you can get to, is how much of an impact a prompt has on your output. Like it's like even for a RAG, like the first time I tried putting a bunch of documents, and you started chatting with it, and the results were not way off, but it was just like off. Like it wasn't.
You were surprised
talking
by the output.
Yeah,
like what? Where is this coming from?
Exactly. Yeah, there was, and then I realized, I looked at the prompt, I had something slightly off. Like it wasn't tailored to what I was looking at, and I probably spent the majority of it was pretty easy to set up. Have LangChain set up, embeddings done. All of that was pretty. Not straightforward, but it's kind of like traditional software. Like you can get there through a lot of prompting the agents itself. You can build something pretty usable, but then the next step was all about the prompt. Like it was just fine tuning it, or actually fine tuning is a loaded word.
It's a loaded word.
Yeah. But it was like refining the prompt until it was like, okay, I'm satisfied. I'm happy with these results. And make a prototype is like, if you feel like the AI is kind of going off the rails, just ask it to say, I don't know.
Yeah, totally. The thing I think is interesting thematically in a lot of these patterns, and it was something that surprised me when I started working with these abstractions and with agents. I actually was a little blind when I started to the usefulness of actually using the LLM as an arbiter for its input and output, or like having two LLMs judge each other's input and output. I think that's really cool. That feels like science fiction to me. Like talking to two computers, getting like essentially two things to talk to one another. They're debating things, essentially trying to like check each other, right? I'm thinking about like the guardrail patterns, right? Where you can even have an LLM check the usefulness of a specific query against, is that actually okay, right? Versus just prompting it, right? I think that's really fascinating. So it's the meta pattern that I see. See what I did there?
Yep. There's a handful of things that all these projects are going to have. They're going to have some guardrails, especially conversational. Most agents we're building are not conversational interfaces. They're ambient. They're taking like they're popping a ticket off of a queue or something like that. Yeah. So some of this stuff goes away if you're not building a conversational interface. But like if you're building a conversational interface, and then the Martin Fowler article we'll share is like really about RAG. Yeah. But RAG and especially conversational RAG versus like a report or research RAG, also very different, is always going to have the same exact things. It's going to have some sort of guardrail to make sure that the user isn't abusive. It's going to have some sort of re-ranking and grading system. It's going to have some sort of hybrid search. It's going to have some sort of its ability to search the documents, right? It's going to have query rewriting and multi-query. And if you don't have those things in a RAG, it's probably not a production grade RAG yet. And then you're going to have some eval. And then that's when it turns into an agent. And even a research-based RAG, non-conversational RAG, will have most of those things. I just might not worry as much about user abuse, right? Because it can only research a certain set of topics, or it's running a background job and just looking at my competitors' websites and seeing what they're up to. Then I don't need guardrails. I have something else. I just don't need that. But I still am going to re-rank. I'm going to make sure that all that stuff is there. I think right now what we're seeing is not software development patterns emerging for agentic development and agents. What we're seeing are the beginnings of them, which are best practices or common implementations that handle shortcomings of the LLMs. And so ranking, grading, and research for a RAG is because LLMs hallucinate. There's a really cool set of research, and I actually have a LinkedIn post, like and follow.
Yeah.
Well, find me on LinkedIn. But I have a LinkedIn post that talks about consensus-driven LLM or agent architectures actually increase accuracy fairly dramatically, and you have multiple different agents. So you might have ChatGPT 4.0 talking with Claude for Sonnet to decide whether or not this output is good, because these foundational models have different personalities, different shortcomings, different training, different weights. If we have consensus added in, then we can get to a higher grade result. Now that higher grade result comes at the cost of inference time, because now I'm letting those two, essentially I'm having two agents discuss an output before they give the output for a certain set number of tokens, and that set number of tokens takes time. And we're seeing this happen in reality. If you go to the Grok 4, super heavy subscription, so the $300 a month one, and you do a heavy query on Grok 4, it actually spins up 4 agents, and then they reason with each other for a certain set number of tokens before they return, and it's outperforming the results of a single foundational model. And so it's not quite a reasoning model, which a reasoning model is using it's one agent using its own token set to kind of think through a problem. The multi-agent architecture or consensus-driven architecture is showing some pretty dramatically improved results. But It's slow, really slow.
Right.
Think 15 minutes for a conversation kind of thing.
Right. Yeah, I don't think it's a coincidence or anything that a lot of the patterns that we're seeing in this article are specific to RAG, and we did call out ambient agents. Do you think, Austin, I'm really curious about this, the things that we've learned from RAG, how much do you think that that's influenced the way that we think about tooling with ambient agents? Because I think that there's kind of that checkpoint for an ambient agent.
Oh, totally. And
tool.
Okay, so every few months a new agent or a new foundational model version is released. Context windows are growing. We're at 2 million token context windows for some things. We're in the 250K for most things. And so everybody's RAG is dead,
right?
Because honestly, the retrieval and search stuff could actually go away if I can fit entire code bases, an entire corpus of corporate documents into a context window, because then the LLM can just needle in the haystack out stuff, and I don't need embedding, vector search, semantic, keyword search, regrading, re-ranking, chunking, all that other stuff. So RAG could die. I think that RAG is but for now, and actually even in the large context window stuff, RAG gets, if you've done right, which is a search problem, not an LLM problem, if done right, so the search is done well, then you can give really specific, useful context to an LLM, and that's also super important for agents. And so like almost every project we do has some sort of retrieval augmented generation. Now, a lot of people think of RAG as like I give a whole bunch of Word documents or PDFs or something, and then I can like chat with my docs. But if I have, you know, emails, if I'm a claims processing agent doing remediation and settlement of claims at an insurance company, I will like use RAG to look over my claims payout policy, and I will use RAG to look at like the conversation that the insurance company has been having with like one of their insured. Right. And so RAG gets the policy documents and the conversation get put into the prompt as part of the generation, so it has context over what to do, because it's not in the training set. It's not in the original weights of the model. And so like RAG and all of those patterns around RAG are core architecture to building any agentic system. I think that's what you were asking.
Yep. Yeah. It's funny. I think about it in some ways. It's like the way that these patterns evolve. It kind of reminds me of kind of a corollary I think of is when you're writing C, like a low-level language, you're thinking about the memory address of something. Like, you know what I mean? Dynamic allocation at that lower level. Some of these patterns that are very lower level and fundamental for RAG feel like kind of the agentic equivalent of that. So the takeaway here, I think, is that there will be bespoke, like specific abstractions that are created to tune these things, or at least get more performance out of them and interface with them.
And if you're at a big enterprise, like there are, we talk about this, like how do you distribute parts of your, like essentially widgets to the rest of the devs at the enterprise so that they can interact with things in the same way. You could have a sub-agent graph distributed that is like RAG over my claims remediation policies that can be plugged into n number of agents. And you should, like, and that one product team would own the policy and procedure RAG. They would have eval over that. They would distribute that as a service. And that could either be called via an API, and it's just like, you know, we hit it, or it could actually be installed like as a Python package. And one of the cool things about LangGraph is you could package it in either way, and install that subgraph in either way.
So the one thing interesting that you called out, like when we think of this new paradigm of like the agent experience, like the agent kind of taking over and doing these things, it's generally thinking of it as like this singular agent that's kind of doing it. But what you're calling out is they could have multiple agents kind of do that work. And I mean, you could, again, going back to patterns, you could have like a conductor, or you could have some kind of, but it's generally like these, an agent is not limited by, it's not a one-to-one, an agent to a human, right? You could have multiple agents take the job of like one human. For
when I think of an agent, it's one, and we said this in the very first episode of the season. To me, an agent is an LLM given the ability to interact with an external system. That's it. So it can search the internet. It can, update a row in a database. It can do something. But normally doing one thing is not enough. So then we evolve that agent graph. So we have like nodes in our graph, and this one can update a database, and this node can search the internet, and this node can look at, the authentication and authorization of the user talking to it. And all of those things work together to create what would be something that could replace repetitive knowledge work at an enterprise, or augment repetitive knowledge work. So yeah, it's and even individual running processes could interact with each other. So then you have two agents that do something and interact with each other like two people would.
Remember to respect the craft. Evolution doesn't require chaos, and teams will always beat heroes.